Today we're looking at section 3.2, which is logarithmic functions. The inverse of an exponential function has many scientific mathematic applications and is therefore given its own name, and that is a logarithm. The form of a logarithmic function, y equals log base b of x. Log base b of x. Logarithms and exponential functions, they are inverses of each other, and so their forms are interchangeable. The logarithmic form, log base b of x equals y, is interchangeable with exponential form, which is the base b raised to the power of y equals x. So b is the base, y is the exponent. In exponential form, b is the base, y is the exponent. So if you have logarithmic form and you're solving it, you're solving for an exponent. The logarithm is an exponent. Log base b of x equals y. Y represents the exponent of the exponential form. That's what it is we would be solving for. So let's look at example 1. Write the expression from log form to exponential form. The first one we have is log base 3 of 9 equals 2. Okay, so we pick everything apart. B, the base, equals what number? 3. X equals what number? Nope, careful. What's x in this form right here? 9. And what is y? Okay, so now when we write it to exponential form, it's the base of 3 raised to the exponent y, which is 2, equals the x value, 9. 3 squared equals 9. When you change it into the form, you need to make sure that it makes sense. Okay, so that you've done it correctly. 3 squared equals 9. The second one, log of 100 equals 2. What is the base of that logarithm? Why is it 10? For some reason, it's automatically 10. Okay, so it's called, this one is called the common logarithm. The common logarithm, the base is 10. When it is the common logarithm, the base isn't going to be written. It's understood to be base 10. The calculator log button is base 10. Okay, that is the common log button on the calculator. So knowing it's base 10, let's change this logarithm into exponential form. So a base of 10 raised to what power? 2 equals what? 100. Question? Just because there's no base written, so it's the common logarithm, and the common logarithm is base 10. Okay, question? Because that's my y value. Log base b of x equals y. Exponential form says b to the y equals x. Okay, other questions? Now, one of the important log functions has e as its base, and it's given its own special notation. Okay, that is the natural logarithm. The natural logarithm has the form y equals ln of x. Y equals natural log of x. Okay. The base of this one, it is base e. And on the natural logarithm, the base is not listed. The exponential form is the base of e raised to the y power equals x. Yep, that's the exponential form. Okay, so let's look at example 2. We are going to simplify these. We're going to simplify them. The first one we're going to simplify is log base 6 of 36. Now, since it's a logarithm, my main form for the logarithm up above, log base b of x equals y. So on this one, I'm going to set it equal to y. Remember, I'm solving for an exponent. Now let's rewrite it in exponential form. So you always start with the base. What is the base? Raised to the exponent, which is equals x, which is, okay, so now let's think about this. 36. What do you know about 36? Okay, if you square root it, you get 6. So could I rewrite 36 as 6 to what power? It's 6 squared. So what does my exponent have to be? Y equals 2. My exponent is 2. 6 squared gives us 36. Let's look at the next one. Log base 4 of the cubed root of 16 equals y. So now we're going to change this into exponential form. What's the base? Raised to what? Equals what? Cubed root of 16. All right. Cubed root of 16, that's written as a radical. How else could I write that? (16) to what power? To the 1/3. I can write it using rational exponents. Okay, so that's what we have just done the past couple of days. I need to now change that radical so it's 16 to the 1/3. Power divided by root. So 4 to the y equals 16 to the 1/3. Now it's 4 to the y. So 16. Can I write 16 as 4 to a power? 4 squared. So I'm going to rewrite this 16 as 4 squared, and then it's raised to the 1/3. Well, what happens when you have a power to a power? Multiply. Multiply them. So 2 times 1/3 is what? No. No. 2/3. So that's 4 to the 2/3 power. So if we have 4 to the y equals 4 to the 2/3, what does y, the exponent, have to be overall? 2/3. Be careful on your multiplying, okay? This is basic math, multiplying a whole number times a fraction. 2 is over 1, you multiply across 2/3. Okay? All right, let's look at part C. The natural log of 1 over e squared equals y, the exponent. The natural log, what is the base of the natural log? Okay, is that e currently written down somewhere? No, it's not. It's understood to be base e raised to what power? E to the y equals, what's in the position of x? 1 over e squared. Okay, so let's look at that 1 over e squared. Is there a way that I can write that so it's not a fraction? E is an actual number. There's an E button on your calculator, and when you do e to the first, that number is 2.7 something. It's irrational, so it never, the decimal never repeats, and it continues forever. Okay, so e is an actual number. But what are we going to do with this if I don't want that written as a fraction? No, we don't want to multiply it on both sides. Think about what we just learned with exponents, Michaela. Bingo. Okay, what did we just get done doing with all those exponents review and worksheet? We took care of negative exponents. Well, this doesn't have a negative exponent, but it's in a fraction. If I don't want the fraction, I'm going to change it so that the exponent is negative. Is that not the same thing? It's the same thing. 1 over e squared is the same thing as e to the negative 2. Okay.
So the answer can be negative?
The answer could be negative. So what is our exponent for this one? Negative 2. Our exponent is a negative exponent. The answer is y equals negative 2. Correct. When you're simplifying an exponential function, you don't want to leave a negative exponent in your answer. Here we're solving what is the exponent. Well, the exponent was, in this case, negative 2. Okay. Yep, here it's okay. Let's try the next one. The natural log of the square root of e to the 11th. We're going to set that equal to y. What is the base of this natural log? So we say e to the y equals what? Square root of e to the 11th. Now let's look at the square root of e to the 11th. What is the root of that radical?
Squared.
Squared, so that's a 2 in there. So how else could I write the square root of e to the 11th? E to the 11 halves, 11 over 2, equals e to the y. So what is our exponent? 11 halves. 11 halves. Okay. Now, over in the corner, some special logarithms to know. The natural log of 1 equals 0. The natural log of 0 doesn't exist. It doesn't exist. The natural log of e. Well, what did we just say the natural log and e are in relation to each other? They're inverses. What do you think that's going to equal? 1. That is correct. It equals 1. The natural log of e. They're inverses of each other. So what do inverses, what are they doing to each other? They're canceling each other out. Okay? They cancel each other out. Think about x squared and square root of x. What happens when you do the square root of x squared? They cancel out and you're left with x. Or if you do the square root of x, quantity squared, they cancel, you're left with x. Same thing with the cubed root of x and x cubed. They cancel each other out. That is the same thing with natural log and e. They cancel each other out. That's the same thing with the logarithm log base b of x equals y and exponential form b to the y equals x. They're canceling each other out. Okay? They undo each other. Okay. Any questions on anything on this front side? All right, let's flip it over. Example 3, convert each to its inverse form. So we're either given logarithmic form or we're given exponential form, and we have to convert it to the other. Okay, whichever one is its inverse. So the first one, natural log of e to the x. This is log form, and on log form it equals y. So its inverse form is exponential. So the exponential form, we have to start with the base. What is the base? So e to the equals what? E to the x. That's what? Oh, that's pi. Oops. I did not see that as pi. Okay, pi. So what's our exponent? Y equals pi. Okay. Let's look at the next one. E raised to the natural log of 5. This one is in which form? Is that log form or exponential? Exponential. So exponential, the basic form says that equals x. So if I'm going exponential backwards to logarithmic form, then it's natural log of x equals the exponent. And what's the exponent? Well, what's the full exponent? Natural log of 5 is the exponent. So what does x have to equal? Okay. Let's look at the next one. 5 raised to the power of log base 5 of 9. That's exponential form, so exponential form, general form says that equals x. So now we have to change to log form. Log base what? 5 of x equals, what's the exponent? Log base 5 of 9. So in this case, if we're solving for x, what does x equal?
9.
X equals 9. Let's try part D. 10 raised to the log of 6 power. It's exponential, so that's set equal to x. Change it to the common log. So it's log base what? Log base 10 of what? So log base 10 of x equals the exponent. What's the exponent? Log base 10 of 6. So what does x have to equal? X has to equal 6. Now look at each of those. Look at what we started with, and look and see what our answer was. Natural log of e to the pi, and our answer was pi. E to the natural log of 5, what was our answer? 5. The next one, 5 raised to the log base 5 of 9, what was our answer? 10 raised to the log base 10 of 6, what was our answer? What are you noticing? Okay, so do you see how we have a logarithm with the exponential? They're canceling out, and we're left with that part of the exponent. We were left with pi. We were left with 5. We were left with 9. We were left with 6. So let's look at a summary. The natural log of e to the x, natural log and e will cancel each other out. You're going to be left with x, the exponent. E raised to the natural log of x power. E raised to the power of natural log of whatever is going to equal the whatever, x. Now in this case, where you have natural log of x, you have to put that x has to be greater than 0. You cannot take the natural log of 0, and you cannot take the natural log of a negative number. Okay? So let's look at the next one. Log base b of b to the x. What do you think that's going to equal? X, correct. B raised to the power of log base b of x. So the base is raised to the log base b. What's my answer going to be? X. And again, on that one, x has to be greater than 0. The next one, log base b of 1. B to what power will give you 1 every single time? B to what power equals 1 every single time? 0. Log base b of b. B to what power will give you b every time? 1. Now, let's go back and revisit example 2c. So flip it back over to example 2c. Okay. If you're looking at example 2c, the natural log of 1 over e squared, which could be written as natural log of e to the negative 2 equals what? Negative 2. Okay. All right, so let's flip back over. Now that we know those little tidbits, let's look at example 4. Simplify. Natural log of e to the 5x. What should that answer be? 5x. Okay. The next one. 5 times the natural log of e cubed. So I have that 5 out front times, what is the natural log of e cubed? 3. 5 times 3 equals 15. Okay. Part C, I have 6 times natural log of e plus the natural log of 1. So let's start first with 6 natural log of e. That's 6 times, what is natural log of e? 1 plus, what is natural log of 1? 0. 6 times 1 is 6 plus 0 equals 6. Okay, so do you see how those work? Okay. And what if I had 6 raised to the log base 6 of 7x? That would equal 7x. All right, questions? Example 5. Find the inverse of each function. Find the inverse of each function. Part A, y equals 2 times e to the 6x power. Now let's think back the first time we ever looked at inverses with all of our different kinds of functions. What is it that you do to an equation to find the inverse? Switch x and y and then solve for y. So that's what we're going to do this time. Switch x and y. So instead of y equals, we're going to have x equals 2 times e to the 6y. So instead of it being 6x, I need to switch out the x with the y. Okay, so now I have to solve this for y. What's the first thing we can do to try to get y by itself? Correct. Divide both sides by 2. So x over 2 equals e to the 6y power. Okay. I currently have exponential form. What can I change that to? I can change it to log form, which would be natural logarithm. Okay? So changing it to natural log base e of what? No. What are we taking the natural log of? X over 2. Okay? It's natural log of x over 2 equals the exponent. Remember, the natural or the logarithm always equals the exponent. So the exponent goes on the other side of the equal sign. So natural log of x over 2 equals 6y. Now what do? Divide by 6. So y equals 1/6 times the natural log of x over 2. That is its inverse. So I'm going to denote that as y inverse. Remember, the notation for inverse is a little -1 superscript. Okay. Part B, we're now going to find the inverse of this equation. Y equals log of 1/4 x. So if I'm finding the inverse, I have to swap x and y. So x equals log of 1/4 y. Now what? Cannot divide by log of 1/4 because it's the log of 1/4 y. So all of that is stuck together. So there's no dividing I can do. So what should I try to do instead? Can't multiply by 4 because I'm taking the log of 1/4 y. How about we change it into exponential form? Okay? Log of 1/4 y, that is all stuck together. There's no unsticking it by doing any kind of dividing. No multiplying by 4 on both sides because it's log of 1/4 y. Okay? So instead, the only thing we can do is change it to exponential form. Exponential form, we start with the base. What is the base of the logarithm? 10, because this is log, not natural log. So the base is 10. What power do we raise it to? 10 to the x equals what? 1/4 y. Okay, now we're getting somewhere. If I'm getting y by itself, now what can I do? Divide by 1/4 or multiply by 4. So y equals 4 times 10 to the x. You cannot multiply the 4 times the 10 because PEMDAS says 10 is raised to the exponent first before it does any multiplying. So that is our inverse equation. Questions? No questions? Okay. Then I don't think it's listed on your paper, so I need you to find space on your notes. And you are going to work these two problems out on your own. My hint on this was you have to look at this exponent portion first. Oh, let me unfreeze it. You have to look at that portion first, which is the exponent, which says log base 10 of 100. So that, if I change to exponential, 10 to what power equals 100? 2. So that whole exponent simplifies down to 2. So you have 4 times log base 15 of 15 squared. Now, you don't do any changing. You don't try to do 15 squared and get some big number. Nope. We have to use our rules from up above. Using the rules from up above. Log base b of b to the x equals what? X. So if you have log base 15 of 15 squared, then that whole thing will equal what? 2. So all of that right there equals 2. And what do you have out front? And what is 4 times 2? 8. Okay. Now go back and try number 2 again. All right, let's look at this one. E raised to the power of log base 3 of 3 raised to the power of natural log of 7. So on this one, we also have to start with the exponent. The exponent is log base 3 of 3 to the natural log of 7. Isn't that using the same property we just used?
Yeah.
So all of that boils down to what? No. Natural log of 7. Whatever the exponent is of that 3, that's what all of that equals. So now I have e raised to that power, natural log of 7. E raised to the natural log of 7 should equal what? 7.
I got
7.
I got 7, but in a different way. Like,
Right.
natural log of 7, I do it differently. So you know how 7 is always
Uh-huh.
right? I did that. So
Did you change it into natural log form?
Yeah.
Okay.
And then X.
You can do that and you'll still get there, but it is very helpful if you know all of these rules. All of these rules will save you a lot of time. Okay? It'll save you a lot of time. So make sure you know those. Study. Oh, there's a good concept. That is a great concept. Study. Yes. Okay? All right. Yes, I'll go back down.